seats were first created in the 1920s and were perfected around the World War II time, and they drastically increased the safety for pilots and passengers of aircraft when they were crashing. And these ejection seats, while they increase the safety, they also have an extreme amount of physics involved with them, mostly dealing with force and acceleration. One equation that can be used to solve for the acceleration of ejection seat would be Newton's equation, which said that force equals mass times acceleration. And because of the extreme amount of force put on a pilot when he is ejected, and the mass, which would probably be an average of about 140 pounds, then the acceleration is also going to be massive as well. And another way to find out the acceleration is using the equation of velocity final, or equals acceleration times time plus velocity initial. And when we solve for acceleration, we get acceleration equals velocity final minus velocity initial over time. And because the time is going to be such a short amount, when you subtract the two velocities and make it divided by a very small amount, you're going to get an extremely large acceleration. And when someone gets ejected from an aircraft, their typical acceleration is in the 5g to the 20g range. And 1 g of acceleration is equal to the gravity, which is 32 feet per second squared, or 9.81 meters per second squared. So the typical g is normally 12 to 14. The typical acceleration is around 12 to 14 g, but depending on the aircraft, it's anywhere from 5 to 20 g. And the average would be about 117 to 137 meters per second squared for their acceleration out of the plane, which is pretty high.